Everybody, Dr. Marty here, back and ready to start talking about Chapter 6. So we finished up last time with Chapter 5. We learned about lines, right? Linear functions. Learned about different forms of equations for lines and slope and perpendicular and parallel lines and how to manipulate lines and understand lines and use linear equations. Well, Chapter 6 is going to move into what we call systems of equations. Systems of equations. So this is going to be situations where we have more than one equation that we're trying to understand. And in this case, they're all going to be lines. They're all going to be lines, okay? So 6.1 starts with how to solve systems of equations. That's where you have two different equations, and you're trying to figure out a solution to both. A solution to both. That's what we're trying to do. So the first method that we're going to learn for solving systems of equations is graphing. So what you can essentially do is you can graph both of the lines that you're given, and then you can find the point where they intersect. If there's a point where they intersect, that means that that point is going to satisfy both equations. So if we plug that x and y coordinate into both, we're going to get a working equation. So let's see how we would do that. So step one is to make sure that both equations are in slope-intercept form. Remember y equals mx plus b? This is the best form for graphing because we have the slope and we have the y-intercept. It makes it very easy for us to graph. Step two is to graph both of the equations on your coordinate plane. And step three is to write down the point of intersection as your answer. That's x comma y. So let's look at a very simple example. We have y equals 2x, okay? Y equals 2x as our first equation. I'm going to graph this in red, okay? So first of all, our form is y equals mx plus b, right? Y equals mx plus b. We know that m is the slope, and b is the y-intercept. So that just says intercept. Okay? So here we have y equals 2x plus 0, essentially, plus 0. So that means b here is 0, m is 2. Okay? So we're going to start at the point 0, 0 because our y-intercept is 0, so that means on the y-axis we're at 0. And then our slope is 2, so that means we're going to go up to 1, 2 for every 1 we go over. Up 2 over 1, up 2 over 1, up 2 over 1. Now, I'm going to draw this without a ruler, but I'd encourage you to use a ruler when you're actually drawing these lines because we're looking for a very exact point where they intersect. Okay, so that is our first line. Let's look at our second line. Our second line is y equals negative 2x plus 8. So here our b is positive 8, right? Our m is negative 2. So we're going to start by finding 8 on the y-axis. We've got 1, 2, 3, 4, 5, 6, 7, 8. So that's our y-intercept, 0, 8. And then our slope is negative 2. That means we go down 2, 1, 2 for every 1 we go over. Down 2, 1, 2 for every 1 we go over. We can see that that point intersects. Down 2, 1 over, down 2, 1 over. Now I'm doing a bunch of them. You only have to do 3. But doing more of them just makes it a little bit easier for me to graph without a ruler. Okay? So now I'm going to identify what is the point where they intersect. Well, it's right here. Okay? So this is the answer. Okay? Well, what's that point? That point is 1, 2 for x, 1, 2, 3, 4 for y. Okay? So our answer over here is 2, 4. If we plug x equals 2 into both of these equations, we should get 4. Plug x equals into 2 here, y equals 2 times 2, y equals 4. X equals 2 here, y equals negative 2 times 2, which is negative 4 plus 8. Negative 4 plus 8 is 4. So that means that 2, 4 satisfies both of those. Okay? Let's go ahead and look at another example. Example number 2. We've got x equals 2 as our point. As our equation, and then y equals 1/2 x minus 4. Now, I'm going to go ahead and do this the same way, all right, just to be consistent. So x equals 2, right? We know that it's not actually going to cross the y-axis, right? I'm actually going to cross the y-axis. I'll go ahead and just graph what it's going to look like. X equals 2 is just a vertical line. Whoops. Right? And doesn't cross y-axis, right? And we know the slope is undefined. Slope is undefined, which means it's a vertical line. Okay? Our second line is y equals 1/2 x minus 4. Well, here, b equals -4, m equals 1/2, right? This is just slope-intercept form. So b is -4, 1, 2, 3, 4. That's our y-intercept. Our slope is 1/2. Means we go up 1 for every 2 we go over, up 1 for every 2 we go over. We draw our line. Once again, I encourage you to use a ruler. And it's very easy to see right away that our intercept is right here, okay? Which is at the point 2, 1, -1, 2, 3, okay? 2, -3. 2, -3. Now, in this case, we know x equals 2 is always the case, and that means we know that x value is going to be 2 here. So we could have just plugged 2 in and find that. And we're going to see how to do that later on in this chapter. But for now, using graphing, that's how we would do that. Okay? So let's go on. We've got 2 more examples that we're going to do, and then we're going to talk about some special cases. All right? Example number 3 says 4x minus y equals -1. Now, 4x minus y equals -1 is in standard form, right? Not in slope-intercept form, okay? So we've got to convert to y equals mx plus b, right? So we've got 4x minus y equals -1. I'm going to subtract 4x from both sides. I get -y equals -4x minus 1. Now, we have a negative y here, and we want this to be positive. I'm sorry, I didn't realize you couldn't see it on screen. Divide by -1 all across the board. We get y equals -4 divided by -1 is going to be positive 4x. -1 divided by -1 is positive 1. This is our equation, y equals 4x plus 1. So m equals 4, b equals 1. So we're going to come over to our graph. We've got b equals 1. And our slope is positive 4. We go up 1, 2, 3, 4 for every one we go over. 1, 2, 3, 4 for every one we go over. Okay, like this. And we have a line that looks something like that. Okay. Our second equation is -x plus y equals x minus 5. Okay? So once again, we got to convert to y equals mx plus b. So we've got -x plus y equals x minus 5. We're going to add x to this side to solve for y. We're going to do it to that side too. We get y equals x plus x is 2x minus 5. Okay? So our slope is 2. Y-intercept is -5. We're going to go 1, 2, 3, 4, 5. Okay? So we're going to go slope 2. We go up 2 over 1, up 2 over 1, up 2 over 1. Whoops, I went off a little bit right there. Okay? We're actually going to get our point of intersection down here, which is actually one off the chart. It's a little bit hard to see, and that's -3 comma -11, right? -1, 2, 3, -11 is there. Okay, sorry that's a little bit hard to see. A little bit tough without a ruler, but that's how you would do that one. All right, now I wanted to include this one because sometimes it can be like, oh no, it's off the grid lines. We can't find the answer. Every once in a while that pops up, and it's important to recognize that you can continue your lines past the grid lines. You might have to extend them to make it easier for you. All right, final example. example 4, sorry about the bleeding through, I didn't realize these markers were going through. We have y equals x plus 3 and y equals x minus 1. All right, this is going to be a nice segue 1. Okay, so our first one is y equals x plus 3, right? M equals 1 here, our slope is 1. B equals 3. So we've got 1, 2, 3. Okay, and then it's just going to be up 1 over 1, up 1 over 1, up 1 over 1, and so on and so forth. It's a beautiful line. Looks something like that. A little bit off without a ruler, but you get the point. Okay, then we got y equals x minus 1. Well, here we've got the same slope. X equals 1. B equals negative 1. Now, we know something about lines that have the same slope. What are they? They're parallel. Okay, so here b is negative 1. Right? So this is going to give us another parallel line. Uh-oh. So what happens here? Well, here we have two parallel lines, right? That means they never cross. The way that we're solving these systems of equations by graphing is looking at where they intersect or cross. Well, if they never cross, that means there's no solution, right? The lines never intersect. Okay, so that is actually one of our special solutions that we're going to talk about in our next set of notes, which I'm going to pick up right here. Okay, so that is no solution. So all we're doing is graphing the first line, graphing the second line. We've got to convert them to slope-intercept form to do that, and then finding where they intersect on the graph. Once again, apologies for the bleeding through. I didn't realize that was happening. I'll make sure I correct that for next time. Finally, chapter 6.1, or section 6.1, we're going to do a little bit about solving systems of equations where we have special solutions. And we actually just saw a special solution there, but I'm going to go through one other possible special solution in a second. Okay, so once again, we're still following the same steps. Step 1, make sure both equations are in slope-intercept form, y equals mx plus b. Step 2, graph both equations on the coordinate plane. Step 3, write down the point of intersection as your answer. So let's do example 1. Okay, our slope is 2, y-intercept is 4. So b equals 1, 2, 3, 4. Slope is 2, up 2 over 1, up 2 over 1, up 2 over 1. Okay. Then we have y equals x plus 2. Here, m equals 1, b equals positive 2. So b equals positive 2. Up 1 over 1, up 1 over 1, up 1 over 1. Okay. And we find that these two intersect at this point, which is negative 2 comma 0. Right? That is our solution, negative 2 comma 0. Easy enough. That's what we've been doing so far. All right, here are two special examples. This one we've actually already seen, but let's go ahead and do it out. Okay? So we've got y equals 2x plus 3. So m equals 2, b equals 3. So we've got our y-intercept there, and then we're up 2 over 1, up 2 over 1, up 2 over 1. We got y equals 2x minus 5, m equals 2, b equals negative 5. You can probably see already that these are parallel lines, right? They have the same slope. But negative 1, 2, 3, 4, 5, up 2 over 1, up 2 over 1. We graph these, and guess what? They're parallel. They never intersect, which means there's no solution. So in our first example, we had one solution. That's our norm. Normally, we're going to find a situation where the graph intersects. Those two lines intersect once, and that's our solution. Here we have no solution. And then our final example, example 3, is going to be a little bit more complex. Okay? So we have y equals x plus 3. So I'm going to graph that. M equals 1, b equals 3. So we've got 1, 2, 3. Up 1 over 1, up 1 over, whoops, up 1 over 1, up 1 over 1, up 1 over 1. I think you get the picture. I'm just trying to make sure I do this right. And that's our graph. Then we have negative 2x plus 2y equals 6. Well, this is in standard form, and we got to get this into form. So convert to y equals mx plus b, right? So we got negative 2x plus 2y equals 6. We're going to add 2x to both sides. We get 2y equals 2x plus 6. Guess what? Divide by 2, divide by 2, divide by 2. We get y equals x plus 3. Uh-oh. This is the same line, right? The same line. M equals 1 and b equals 3. Okay? So when we graph this, and I'm going to go ahead and graph it just to show you, we're literally going to get the same exact thing. The same dots, same line. Okay? So if we get this situation, right, where we have the same line, there are infinite solutions. Everything is a solution, all real numbers. Okay? Infinite number of solutions. So those are our special solutions. They could be no solution, where we have parallel lines. They could be the infinite solutions if we have the exact same line, right? And then most of them, we're going to see just like this, they're going to have a single intersection point, and that's going to be our solution to our system of equations. So just to recap, system of equations is when we have two, or in some cases more, but we're only looking at two now, different equations for lines. And the first way we can solve them is we can graph them, find the point where they intersect, and that is our solution. Okay? We'll be back next time with another way of solving systems of equations.